Hello, everyone, and welcome to this webinar on Tas Engineering for Everyone. My name is Nagman Khan. I'm delighted to be your host today on behalf of the team at Environmental Design Solutions. Welcome. Let's meet your presenters on the next slide. And I'm going to ask our presenters to introduce themselves one by one, tell us a bit about their history, and we'll kick off with Ian Highton, who's the founder, one of the founders and directors at EDSL. Ian, welcome.
Thanks very much, Nagman. Hello, everyone. Yeah, sad to say it's 36 years now since I've been working at EDSL, so quite a while. Yeah, technical director, but yeah, one of the founders and hopefully one of the better software developers, and yeah, obviously continuing to support and push on the product and the company.
Excellent, thank you, Ian. Paul Bacon.
Yeah, hi there, Paul Bacon. I've been with EDSL nearly 21 years now. I started out in the design office for a consultancy, become a chartered engineer, and then, as I say, joined EDSL 21 years ago, set up the consultancy department, and I've been working there ever since.
Fantastic. Hello to Duncan MacArthur.
Hi, I'm Duncan MacArthur. I'm a software developer at EDSL, and I've been working with the company for 25 years now.
Amazing. And Andrew Helmy.
Hi there. Yeah, so I've got a background in physics. I've been with EDSL for 11 and a half years, and I started in the consultancy services department where I got familiar with the software, and then I quickly moved to software development. So I took what I learned from using the software, and then learned how I could make it better, and then started improving the software. And now I help with the software development and IT infrastructure.
Amazing. What a fantastic team with decades of experience, and really great to see that core team there still going and driving innovation in the building simulation industry. Let's take a look at the agenda for today. I'm going to quickly hand over to our first speaker. We're going to start with Ian on a little bit of introduction to EDSL and the Tas software for those of you who might be seeing it for the first time, including a demo. Then we'll see some of the cool new features we've been seeing, very cool LinkedIn posts about recently, including the GenOpt and the Ambience 3D. And then we'll look at how to access Tas in the cloud, which is very interesting and very new as well. And we'll end up with Paul talking about Tas consultancy services. Please post your questions in the team Q&A section in Teams, and we'll try and get through as many questions as possible right at the end. Ian, I will hand over to you.
Yeah, great. Next slide, please. Yep, hold there for a second. No, back. I got two sets of things. Yeah, don't worry. I was just going to say Tas was originally developed at Cranfield in the 1970s, and there were a couple of oil crises at that time. This is ancient history, really, but it's kind of interesting to know. So we had two oil crises, 1973 and 1979, and obviously a big element of these crises, energy crises, was how we're going to sort of not be so dependent on foreign oil, how we're going to become more self-sufficient. And obviously one of the ways you can do that is to make buildings much more energy efficient. It depends who you talk to. Some people say buildings are 30% of the total energy consumption. Some will say nearer to 50%, but obviously that's a big target if you're trying to reduce energy consumption. In this case, it was particularly oil consumption. I remember back then the schools were shutting down because they just couldn't keep them warm enough, which was great as far as I was concerned. I was about 11 at the time. Yeah, so the next big phase of investment came around sort of late mid 80s, early 80s, mid 80s. It was Legal & General, which if you're not from the UK, that's a very big insurance company who obviously invest a lot of money, and they invested a lot of money in a number of products, not just Tas. And they foolishly tried to give the sales and marketing team the same sales and marketing team across these very disparate products, which pretty obviously failed at the end of the day, but it did mean we could, leave that company and form EDSL, which was 1989. So yeah, that's the sort of ancient history, as it were. We've got slide 5 now. I think you can move on, Andrew, if you wouldn't mind. Yeah, so you can read through that, and it's all very good stuff. I'm going to go maybe a little bit further back. The first project I worked on was PowerGen HQ, and as I say, that was probably late 80s. And it was a fully naturally ventilated building, which was pretty unusual at the time. And this was the first time we had to integrate building airflow and the building simulation. So as it was naturally ventilated, obviously you have to take account of that air movement, the natural air movement, but at the same time you have to combine that with what the building's actually doing. So I think that was one of the first times that we actually had, you know, this combination of building and natural ventilation stuff. And it's a fairly classic design now, but it was radical at the time. Natural atrium with openings at the top, controlled openings at the top, and also you had open plan offices connecting to it. And again, the windows on either side of the offices were controlled. So as I say, it posed a lot of problems for us. I think it was Ernest Griffiths and Son were the consultants at the time. And yeah, I do remember quite a few late nights working with Nigel Griffiths trying to get this thing to actually go, which again, it's good, pushes the software on. Another very interesting project we got involved with Hilson Moran was the 12 St Mary Axe. So this is more commonly known as the Gherkin, and that had, obviously it's got a double skin sort of facade, and it was the cavity which they were using to do natural ventilation when that would work. And again, mixed mode, which was a pretty interesting thing at the time. So if one of the floors wasn't able to maintain reasonable comfort levels, they'd shut the internal windows on that particular level and turn on the air conditioning. Absolute pig of a thing to simulate, because once those windows were shut, they wouldn't reopen again. So there's no sort of no hysteresis, or no, that was it. Once people got used to the air conditioning in that particular floor, they just left it shut. So as I say, quite an unpleasant thing to simulate, but again, pushes the software on, which is nice. Again, government legislation. This time it was all to do with the European directive, so Energy Performance in Buildings Directive. This was 2006. And that was another shift in the UK industry. We went from being a sort of a luxury product, if you like, or discretionary, to being mandatory in some respects. Not just us, obviously there was the government tool SBEM, and there were other, DSM packages out there. But that was a fairly huge step change in terms of the business and the quantity of business that we were getting. And again, Part L regulations were modified, EPCs were introduced, and I think, Paul, am I right in saying you lodged the very first EPC? Is that correct?
The very first level 5 EPC was lodged by myself, yeah.
There you go. So you were the first across the line. Yeah. And since then, we've seen various other sort of regulatory changes, but the big differences in terms of what the software is now capable of and the developments that have been made are very much more about lighting, daylighting in particular. So can you harvest daylight? Can you reduce the amount of electrical lighting gain, artificial lighting gain effectively? And then you've got other metrics now like CBDM, climate-based daylight modeling, which again is a much better way of actually appreciating how window design, window placement, etc., blind controls can give you that sort of optimal performance in terms of reducing artificial lighting. We also went back to component-based HVAC modeling, which is either people love it or hate it. But in America, for example, Australia and Europe to a certain degree, it's pretty much a standard form of analysis. In the UK, for some reason, it isn't quite so prevalent. But I've seen a big change in the last few years. A lot more people are picking it up, using it correctly to try and head towards that net zero target. So that's a key element. And the last thing, which hopefully I'm going to be able to demonstrate a little bit of later on, we've recently managed to take the building simulation stuff and actually import that into our CFD engine, which is quite unique in a number of ways. But it just means you can actually look at a specific space, not just in a snapshot for a single hour at a peak heat or peak cool, for example. You can actually look at the process through a whole day. So that's hopefully going to be a sort of significant change to the procedures that we've got. Next slide, please, Andrew. So in the next few, basic task functionality, but also, as Nagman alluded to earlier, new features from the latest release, which is 957. And then, God help me, I'm going to try and do a live demo of some of the features, which again, hopefully is of interest. And thank you to Inkling for the background image there, which is probably one of the most complicated task models I've seen. Next slide, please. Sorry, Andrew. Okay, I'll let you read through that. I'll be honest with you, Duncan's the expert on a lot of this stuff in terms of the regulatory type calculations. I've thankfully lost touch with that, which I'm not sad about in the slightest. And yeah, lot to absorb in just one slide. Yeah, and hopefully, as I say, we can show you some quick CFD samples a little bit later on. Yeah, so next slide, if everyone's managed to get that. I think we're over to you, Duncan.
Okay. Yeah. So one of the features of the software is that you can optimize a problem. So if you look at this schematic in the top left hand of the slide, there's a gas boiler and a heat pump, and one of those will be used depending on the controller, and the controller is set to a certain set point. So what we can determine is if we change the set point temperatures, what is the effect on the total cost or the consumption or the CO2 produced. So we can pick one of those aspects. So I've chosen the monetary cost of the fuel, and I've optimized based on that. So we pick the variables we want to change. So that's the set point of the controller, and we choose what we're trying to minimize. So I'm trying to minimize the cost, and then it will run a number of simulations for us and try and converge on that lowest cost result, and it will tell us what the set point temperature is for that band. So basically I ran this here and it came up with a value of 5.29 degrees. So if the heat pump's used at or above an outside temperature of 5.29 degrees, then that gives us the lowest cost to run the building, to run the heating system. And one of the points to note is that, you know, we have the performance map for the heat pump. So as the outside temperature is cooler, the heat pump becomes less efficient, and also the capacity of the duty can reduce. So all that is factored in, and the fact that we've got an electric heat source, electric fuel source, and a gas fuel source, we've got tariffs associated with those fuel sources per kilowatt hour. So that all factors in as well. So, but yeah, if you wanted, you could optimize on, say, lowest consumption, and you'd probably get a different result. Yeah. But yeah, this is just an example. It's not limited to this. You can basically take any variable in the software and adjust it, and you can come up with a cost function to try and get the system to, you know, return the minimum cost.
Sorry, Duncan, just curiosity. Yeah. So you can optimize on cost, but you can also optimize on CO2 emissions.
And so you could optimize on you know, CO2 emissions. We could optimize on consumption. So if I chose CO2, the set point is a lot lower because the CO2 factors for electricity that I've used the 2021 monthly figures from the NCM document for the CO2 factors for the heat pump, so for the electricity. So yeah, so the more you can use the heat pump, the lower the CO2, but you need to use the heat pump in an efficient range. Yeah. Okay.
So I was about to say, I think you're on the next slide, aren't you, as well, Duncan?
Yeah, if we go on to the next slide. So some of the things we've introduced to the software recently in the last release, we have ventilation functions where you can now set a set point for them. So what temperature does that ventilation air enter the zone? So that can be set. So that's these ventilation functions, and they're part of the internal conditions. You can add a vent function. Now there's the functionality to set a temperature. And if you do that in the results file, you'll see the load required on that fresh air to meet that temperature. So that's reported separately. So yeah, you end up with the fresh air load and also the room load in the results. And one component we were being asked for a lot was the 4-pipe heat pump component. So obviously, if you've got heating and cooling in the building at the same time, you can use the heat pump very efficiently to basically create the cooling and push that heat, reject that heat to the place that needs heating. So you end up with very efficient COPs. So we now have a component. But I mean, previously you could build that, but you build it from 3 components connected together. So now that's in a single component, so it's a lot easier to use. So, and then we have a weather utility, which makes it easier to bring in weather data, make changes to it, and create weather files. So that's added to the utility section. And some of our we've added some improvements to our network licensing management, where you can log on to a web page now and see which licenses are checked out and who has them effectively. So that's if you need that set up, you can just email support@edsl.net, and there's basically a checkbox that we need to check, and then set you up with an account password, and then you'll be able to go on there and manage your licenses, seeing where they are and who's using them.
Is that just a normal web browser, Duncan? Is that
yeah, it's just a normal web browser. Cool. So yeah, if you'd like that set up, just email support, and we'll do that for you. And then we've got 3D ambience now that we're offering as a consultancy service. So if you have projects, CFD projects, and you already have the building simulator files and tasks, then we can offer you that as a service to model CFD. Okay.
Yeah, I think next slide for me, Andrew. Yeah, I'll give a quick no, back one. You don't have to. It's just I know it's a title placeholder.
I think there's a bit of delay on the me changing it. Apologies.
Don't worry. I still think that's an amazing warehouse model. Quite a spectacular image. Sorry, Duncan, you did tell me how many cells was that?
It's about 12.8 million.
Okay.
Yeah, it's 150 meters long. I think that warehouse. It's massive.
Yeah. Anyway, reminds me of the Amazon warehouses down the road, but yeah. Okay, most current software packages, CFD packages, use a thing called pressure correction to try and conserve mass. Basically, the continuity equation has just got UVW in it, so it's all just velocities, whereas the momentum equations have also got the pressure terms in there. And what you find is, where's my pressure equation? So what you do is effectively turn that continuity equation into a pressure equation by saying, if I change the pressure, can I then conserve the mass? I spent a long time bashing my head against this because it's not a great process. I mean, absolutely innovative in the 1970s when it came out of Imperial College, but you're basically using an omnidirectional variable pressure to try and, alter what is often, mass imbalance is frequently in one direction, X, Y, or Z. So I haven't proven it, but I would possibly guess that pressure correction is unconditionally unstable. So this was the big impetus to try and come up with a much more robust and hopefully better placed tool for people to use within the built environment. So this is it's leading on to the next step where we can actually take the building simulation results into the CFD, which Duncan mentioned just a little bit previously. I did, this is going back a few years now, but the ambient solver, I think it's got 5 unique features. So yeah, and it implicitly conserves mass without having to to use the pressure correction processes, which clearly hugely improves stability. One thing I haven't mentioned is actually we've got quite a good CFD validation page on our website, lots of standard cases, etc., etc. So that's worth a look if you get a chance. Okay, thank you, Andrew. Okay, I'll let you read that stuff. Typically, CFD simulations currently are steady state, so you're effectively picking a peak heating or cooling hour on a particular day, and you're trying to get a visual representation of the airflows and the temperature distribution across the space, which is okay, but it doesn't really give you a feel for what's happening dynamically across that space through the day. So, you know, when the heating turns on, how long does it take for the average air temperature to, you know, not steady state, but sort of get reasonably up to the design temperature that you've put in? And you know, do you have cold spots? Do you have problems? Do you have cold downdrafts? A consultancy job we had recently was that they were putting light shelves into a classroom, and it was the upper window that was opening, and they were worried that previously the air had just shot down past the window and down the window ledge, but with the light shelf in, they were concerned that the cold air would move across the light shelf and then just dump onto the poor kids. And guess what? It did shoot across the light shelf and then dump onto the kids. But having a bit of software that can actually demonstrate that and show you when the worst circumstances are, either through a summer condition perhaps, or a mid-season condition, or probably we went for winter conditions, which is probably where you're going to get the biggest delta T's and the buoyancy forces. So it's important, I think, to have the dynamic aspect of the air movement within the space coped with, and you know, then you can say with some certainty that your design is going to be robust, you know, in all these different circumstances. You're not limited, as I say, to, you know, one configuration, 1 hour, and one point in the year. You can actually start to look at a much wider picture, and hopefully, you know, it becomes a much better design tool for that at the end of the day. So yeah, again, my last point to make on this slide is the only thing we're going to see is hardware getting quicker and quicker, which means these sorts of calculations become even more, you know, quick. They become much more repeatable. You can do more options. You can get more design, you know, issues sorted out in a relatively decent space of time. So it's almost like CFD's keeping up with the building simulation a bit better. To stress this, it's still a consultancy tool because there are still some wrinkles involved with the HVAC side of things. It's pretty good for naturally ventilated aperture type flow stuff. But again, we've still got quite a lot of work to do. So I can foresee a few months, you know, 6 months, 9 months, where we're going to be continuing to work on this as a consultancy tool. But if you've got, you know, TAS files, if you've got TSD file or TBD, T3D files, we can work off those very quickly and easily. So, you know, it's no longer the sort of massive cost and huge timescales that are typically seen in the industry when you're trying to use CFD. So hopefully we can broaden the market in terms of its use. Right, and I think live demo time. Yeah, I'm going to quickly share. Hopefully this will work. We did test it earlier, so. Okay, so to kick off with a couple of things that, sorry, can you see the screen? Nod, good.
Yeah.
This isn't the CFD side of things, by the way. It's just something that I'm not sure sort of everyone perhaps appreciates. So I need a keyboard for this now. So one of the things that we're fortunate to have is a decent 3D modeler. So you can actually just move these things. So if you're looking at, you know, architectural changes, and you're having to sort of adapt, it means you don't have to just destroy everything and replace everything, which is incredibly useful. Yeah, again, a lot of the developments in TAS have been based around the fact that you use the software in-house, and you have to be able to do this kind of stuff, and it just makes life a lot more efficient. Actually, I'm not sure if it bans you from. We've recently added a feature where you can actually stopping you at the window. You can actually pin windows now and put a wall through there. Another nice example of being able to do this kind of stuff. I'm looking at. Oh, that's typical. Sorry, the little team sharing window is just in the wrong place. I can't move it. Oh, what a pain. I think I'm going to have to just do my best to. Yeah, I wanted to draw that as a divide, but I'm going to have to draw it as a real wall. Now the key bit here is you can see it's named. It's the same zone, and it's named it. And I am going to have to find a way to move the blooming thing. Oh, there we go. Found it at last. I had this with another package recently. So the neat trick is, it's as you've drawn that line, it's worked out that there are now 2 spaces. So it means that if you did want to, set this zone, where are we? Set zone. That's the one. That's it. You're done. So you don't have to delete anything. You can just update the floor plans effectively, draw the necessary walls, and the software is smart enough to figure out, okay, so you've made some new spaces here, which means you can assign different zones to it. So yeah, handy, but yeah, part and parcel of the process. I'm not going to say no to that. Yeah, in terms of the building simulation, we've got, where are we? Here we go. Yeah, so if we want to use the CFD at the back end of this, we need the aperture data and the temperatures for the apertures being output, and then we obviously need to assign that. Sorry, it's building elements we need to assign it to. So you drag these in here, and you get the necessary controls put through on that. One of the nice features we've added recently as well inside the building simulator. Hey, hasn't come in the wrong place. So you can visualize where certain building elements are, which seems pretty obvious, but it's kind of nice to see, exactly where these things are. So that can save a lot of time figuring out, that exposed floor, for example. You've obviously got the walkway going through, and it just very quickly and easily sort of demonstrates where the actual surface is. Likewise, external walls, ground floors. Yeah, you get the idea. But it's got kind of a nice feature so that you can sort of forensically look through the building and figure out where all this stuff is. And as well, you can see sunshine availability. If I just pick out, oh, that's not a good one. Let's go office. There you go. So you can start to see how much sunshine availability you've got on certain surfaces, and I think you can look at insulation levels. So again, pretty obvious. You can see the variations. Oh, let's forget this. You can see the variations quite quickly and easily. As I say, I'm probably the worst person in the world to demonstrate this software. And again, clearly you're going to see much higher levels if it's south facing, and much lower levels where it's north facing, which again, perfectly logical. Good. I think that was all I wanted to cover there. Yeah, in which case I'll crack on with the CFD stuff. Yeah, we had some problems with this earlier today, so keep your fingers crossed. So this is the training model that some of you will be familiar with. And when we pull this in, it basically lists out all of the zones. We need a decent shift select, but this will do for now. Sorry, Andrew, did you do the circulations on this one?
Yeah, I did the circulation. I stopped at reception 1. I didn't go any lower than that.
And what was the cell dimension you used?
Which version? It depends which version of Ambience you've got. 0.12 is
0.19. I think I'm using the latest one.
Okay, yeah, then 0.2, 0.19, anything's fine.
Okay, I'll go 0.19.
You've got 2 points there, Ian. 2
Oh,
points.
thank
in
you.
the box.
Any day and hours?
Yeah, any day's fine.
I'll go with 176 in that case. And this is going to start the simulation at hour 8 and finish it at hour 16. I think I'll start at 9. Step size is basically how often it changes the surface temperatures. Surface temperatures are interpolated, so it's not that critical. The alignment angle is just in case you've got a skew whiff building, then you can change the alignment so that you line up with the CFD grid better, and that just saves a lot of hassle. I mean, obviously still, you know, maintains the information about orientations, etc., etc. Yeah, that's just a quick box to let you know how big you could make the cell size. This isn't a wickedly fast PC, so it's only 8 cores and it's not radically fast. Yeah, so you can't see what I'm doing with the mouse, but middle button drag is move, and right button drag is zoom in, zoom out. So it's the usual kind of stuff. Is this coming through relatively smoothly? Because it looks smooth. Listen, okay, so you're getting the stuttering. Yeah, fair dues.
Yeah, a little bit, but it's not too bad.
Okay, this resolving inlets is, well, that's gone again, but that's basically taking the airflow through the apertures from the TSD file. This resolving boundaries is much more to do with the fact we've eliminated pressure correction. So the methodology that we use requires, I'll just turn these XYZ slices off so you can see. This is a thing called an ISO surface. So at the moment, this is showing you where all of the 20-degree elements are. And obviously, if you drop the temperature down, you can see where the air's coming in. And as you get hotter, hopefully you'll see some more interesting activities. Yeah, there you go. So you can see these plumes rising off the people and the bits of equipment. So it looks like a weird sort of red mushroom field, but. And yeah, if you look in the top left, you've got the elapsed time. So it's done about half an hour already, which means we should get. And as I say, actually I'll turn that off. Just pull the XYZ slices in. You should be able to see, as I say, some of the dynamic stuff going on. Yeah, we're not, so I need to raise that up a bit. You can change the temperature scale. 15 is obviously a bit low, so if I go 18, that's probably a reasonable stab at it. Oh, I've gone too high. Typical. You can see I've practiced this a lot. And again, you can rotate, sort of zoom in, see what's going on. Unfortunately, while you're rotating and doing all that stuff, the simulation stops. And I think we're at, where are we? Oh, we go. 1 hour 20. So what you'll find is when we get to the hour change, it will bring in the new aperture flows, and then you should see quite a significant change. Yeah, we got contours. They're kind of funky. Not sure that helps particularly, but yeah, and this line integral convolution, which takes, it's fascinating actually. All this visualization is great, but we found that it absorbs about half of the CPU compute power. So just visualizing it takes a huge chunk out of the calculation capacity of the CPU, which is fair enough because it's drawing a lot of lines. So you know, it's not unreasonable. Line integral convolution, which always just looks like Van Gogh to me. But what it's trying to show you is the airflow temperature, obviously with the color, but it's also giving you the localized pattern of that airflow. I'm starting to realize it's a little bit more useful than I'd originally thought. Yeah, I was hitting through a wall there. Oops. Sorry, I should turn the simulation off while I'm trying to drag these things around.
Yeah, LIC is quite intensive, isn't it?
Yeah, yeah. Not a good one to demo this on particularly, but you can also drop other slices in there. Yeah, I mean, you can start to get in sort of visual overload. Again, some quite nice images. Yeah, so you can have 3 sets of 3 slices, but in all honesty, you do start to get, as I say, into yeah, not dubious territory, but yeah, it's certainly a bit scary.
Ian, We have a question live about this topic from Kartikeya. He's asking, does the visualization account for the dynamic airflow from the windows that was mentioned earlier in the visualization?
Yeah.
Correct.
Yeah, I didn't pick a good example here, I'll be perfectly honest with you, because the only inlets and outlets we've got at the moment, which is the pink and cyan lines, are actually internal. So I should have chosen a far better example. And I think there's a Ballymore video that we could post, which shows, you know, how the apertures are opening and closing through a whole day, and you can actually see the cold air spilling down. I'd meant to dig that out, but we had some issues this morning, which would, holding us back. Have you got access to that, Nagman? Can you? Or can someone stick that video in the chat or a link to it? I think it's 17, 20 megabytes. It's not huge, but that absolutely shows, you know, if these were apertures, then you'd 100% see the airflow coming through.
You can see streamlines as well, can't you? And you can do particle tracking for when you've got the natural ventilation added in the model as well.
Correct. Yeah, as I say, this wasn't a particularly fine sample to go at. I might quit this one and try running another one. Are we okay for time, Nagman?
Yeah, let's crack on. We have a lot of questions to get through, Ian. There's a lot of interest in this, so we want to leave plenty of time for questions as well.
Okay, well, let me just quickly see if I can fire up for what I'm doing now. I'm not sure if this one's got samples on it. See, we're well prepared for this. So this is what I was talking about with the power gen headquarters, funny enough. So it's a sort of classic, oh God, I don't know. Let's try 0.2. This process is really quite sensitive to cell size. So I'm going to go 0.2. What the hell? Quicker by the sounds of it is going to be more important than anything else. Yeah, so if any of you have done the training course, God, I'll tell you, this Teams bar thing, I don't know if you guys see it, but
no, we don't see it.
It's perpetually in the bloody way. Right, let's hit go and then worry about things. I remember this one takes a bit longer. I probably should have gone with a bigger cell size. I mean, you know, sort of that plus a bit cell size.
If you undo the render box, it'll resolve quicker as well.
Does it? Oh yeah, there you go.
Yeah, strange, isn't it?
Here we go. Let's turn those off. Just quickly have a look at the ISO surface. Yeah, so there you go. Not sure if, no, this one, oh, I'm sorry. This one is, oh, no, this one's again, it's only internal. The Ballymore video is the one to go for. Again, you can see the plumes coming off the heat gain regions, and you've obviously got some, maybe that is coming from outside.
Ian,
yeah,
I wonder while you're on this topic, we can take quickly a couple of the CFD questions just while it's fresh in our head. So one attendee is asking, for the Ambience 3D CFD, what outputs do you get that can be in what form? How usable is it as an output for an engineer to use themselves to do something with, apart from the visualizations?
I've just shown you temperatures and sort of streamlines and ISO surfaces, and you can do the slices, etc., etc. You can also look at mean temperatures, and you can also export and do, well, at the moment you have to export it. Eventually it's going to be built in, but you can export to another package where we can actually do the mean radiant and resultant values.
Yeah.
We've got plans. We've got plans to do, you know, PPD, all of those sorts of things off the back end of it.
Yeah.
But again, as I say, at the moment, this is very much a consultancy tool, and I would say it's not heavily in development because you can see that it works and it runs.
Yeah.
A bit miffed I haven't got a set up. The Ballymore video, that's, if we can post that, that's absolutely the clearest and fastest way. Just watch the video, which is quite short, and you can see the windows and the apertures opening and closing. You've got the nice nighttime cooling draft coming through the windows. Sorry, I should have thought to put that together, but as I say, we were fighting fires this morning.
Yeah, we'll send the link to that as a follow-up to this webinar. So if you've registered for this webinar and you're attending, you'll get that this week. Just quickly, while we're on CFD, there's a question from Nuha about how does the Ambience 3D handle large complex models with a lot of cells, and traditional legacy software has, convergence issues, especially when trying to solve for pressure velocity coupling.
Go back and look at the factory that we did, which was 12.5 million cells. And when we were doing comparisons with Hilson Moran, who were using Fluent, I think we got up to 64 million cells. So that was 200, 200, 200, I think.
Yeah, we did.
No,
we did
400, 400, 400, beg your pardon. Yeah, and the comparison was, I mean, it was taking us maybe minutes, maybe an hour or so, and I think it took Hilson Moran with Fluent 3 days. So, there's that order of magnitude sort of shift in terms of the speed of the thing. And no, I can't tell you why it's so fast. I can.
Secret. Don't tell it. Don't tell
no,
anyone.
No, I gave far too much away at the building simulation group, but if you go look at the validation stuff, that's the key thing for me. Great, it's fast. Yes, it makes pretty pictures, but is it accurate? And the validation stuff is pretty much 100%. Yeah.
Ian, let me squeeze in one more question on the CFD from Kartikeya. I have to squeeze this in because Kartikeya and I were mates and we go way back. It's a great question.
You'll get a telling off.
No, a quick question. The current time step in TAS is 1 hour. How is it further subdivided for CFD, and are there plans to reduce the time step to 15 minutes in the future? And this is really interesting because this is a lot of people think this, Ian. So you tell us the answer.
Without giving too much away, the time step for each cell is worked out by that cell. So in very fast moving areas, it's going to be a very small time step. So where you've got inlet registers, where you've got openings, apertures, fast moving air, I'm not going to go much more than that, it will automatically use short time steps. And where it's slack in the corners, overnight when it's stagnant, the time steps get much longer, which is where we get the speed from ultimately.
There's also a point which is quite important actually. So in the question, he says, since the current time step in TAS is 1 hour, that's a bit of a misconception, isn't it,
yes,
Ian?
True.
Yeah.
Which is quite an important one, actually.
Yeah, and I need to fill that one in because lots of people say that, the time step is 1 hour. No, it's a Laplace transform solution of the Fourier heat conduction equation, which means it's analytical, which means our time step is effectively infinitesimal. We happen to report hourly because that's just the way the weather data works. And all we get is weather data for the previous hour average. So in all honesty, there's not a lot of point us reporting any more sort of accurately in inverted commas. There's nothing to stop us reporting continuously. And if you look at the validation work that we've done, you've got ourselves, you've got ESP, you've got Energy Plus, you've got IES, all within 0.6 of a degree through all of the TM33 tests, which is bizarrely withdrawn tragically, but you can still get hold of it. It's a very good set of tests actually.
Brilliant. Let's crack on. We've still got a few slides to cover as well. Carry on, Ian.
Well, I need to stop sharing, don't I?
That's all right. I can. I think I'm the next bit. So.
Oh, sorry. I hit stop sharing. Oops.
There we go. Hopefully you can see.
Yep, you're back.
See TAS in the cloud. Yeah, exactly. Yeah. I'll just give you a bit of background on this. So cloud computing, that can mean several different things. But in this case, what we're talking about setting up a machine that's hosted in the cloud that you can remote into and use like a normal computer. And the reason we've done this is because I went to see some customers a while ago, and they told me that they have quite a lot of trouble with their IT department getting the latest version of the software installed. They said that it can take up to 6 months and cost them thousands of pounds just to get even an update to the software that they're currently using installed. So we figured other users might have that problem as well. Even if they don't have our software and they just want to try it, we just want to make it quite quick and easy for them to be able to go to a web browser and try the software. So what we've done is we've set up a pool of cloud machines that users can connect to use the software. So if I switch to the next slide.
I've actually used this, by the way, and I was surprised by the I was expecting latency, sort of like, oh God, I'm working through a web browser. It's going to be really sluggish and it's going to be very irritating. No, almost as responsive as the desktop version.
Yeah, so I'll play this little video here which shows you what it's like to use, just so you've got some idea what to expect. Basically, you just go to, I'll pause this video as well because it's a bit slow on Teams screen sharing. You just go to windows.cloud.microsoft, and then once we've added your account to our system, you'll see a list of machines. So here you can see this one has been set up for ambience, for demoing a special preview of ambience, which we've given to some people. So you click connect. and then you can choose whether you want to use copy and paste and things like that to get files in and out, which can be quite useful. It's also, it's a full Windows 11 machine, so you can use the web browser, you can use the other Windows applications that you're used to. And then here we go. So here you can see the machine, and then you'll see me make it full screen in a second. There you go. And at this point, it's quite hard to tell that you're not actually using your local machine. So you can see on the desktop there, you've got the task manager, you've got our special preview of ambience, and these machines are quite powerful and flexible, so we can change how powerful they are, how many resources they've got. This one's got a colossal amount of resources. It's got 400 gigabytes of RAM, which is way more than anyone will ever need. We don't come anywhere near that. I say that, but the way that our technology is progressing. But you can see here, this one's got 36 cores, and it spins through the ambience extremely quickly. So yeah, if you are interested in that and you just want to try Tas, just send me an email or send an email to support@edsl.net, and yeah, we can set you up with a demo, a trial.
Amazing.
So now we're over to Paul, who is our consultancy services manager.
Director.
Yeah, indeed.
That's right.
So as I said, I've been at EDSL 20 years now, and in that time we've worked on thousands of different projects. Tas will take, as the consultancy department will take on any project, whether it be a single zone model all the way up to 5,000 plus zone hospitals, which we've done many of in the past. Whether you're a current Tas user or not, we can still help with your requirements. If you're a Tas user and need assistance due to your workload, then this may be by helping you just build geometries, passing them back to you for analysis, or taking over projects that you started. If you're not a Tas user, then we'll carry out the whole project from conception to as built, and for some post-occupancy evaluation, if you want those options too. So most of our clients are consultants, contractors, architects, building owners, facilities managers. Some of our clients we work with have been coming back to us for over 20 years as they are happy with the speed and the service and reliability of our services. One major advantage of having an in-house consultancy here at EDSL is that if something new comes up that's never been modelled before, we can speak directly to the development team and they will make changes and improvements.
I've got to butt in here, because there's nothing quite as what's the word, motivating as having Paul stood right next to you going, it doesn't bloody work, and I've got to get it out the door. Yeah, so very true.
Ian and the others have helped me come over some problems in the past very quickly. I remember the Leadenhall project, also known as the cheese grater, which had a solar tracking type blind system and different solar intensities on different facades, and no modelling software could do that back then. But a couple of afternoons and you had it all fixed and you had functions for me to be able to do that. So it's great having the consultancy and the development team working sort of side by side.
Yeah, true.
Some of the services that we can offer, Part L, EPC for England, Wales, Scotland, overheating analysis, BB101, TM52, TM59 for domestics, thermal comfort, predicted mean vote, predicted percentage dissatisfied, energy models, TM54 calibrated energy models, can be great for facilities managers and building owners to see potential payback on investments, help with BREEAM credits, health and wellbeing, visual comfort, energy, LEED and Green Star credits too. Simple things such as, well, not simple to everyone, but room heating loads, cooling loads, building simultaneous loads, plant loads, we can do it all. Daylight factors, rather than using standard BRE calculations that you get in a lot of simplified tools nowadays, we can do a more accurate calculation, and this can show improved reductions on energy when it comes to daylight dimming. Yeah. Climate-based daylight modelling, right to light, new developments, extensions, sun path, shadow analysis. And if you are quite competent or quite new, then we can carry out a check-in service for you as well. So, if you want to give it a go and you're not quite sure, send it over to us and we'll sort of give you a bit of validation that what you've done is right and give you any comments back on those models. And then finally, as Ian's already touched on, the 3D CFD consultancy, which is a new thing we're now offering. So whether you provide us with your Tas models, we will then do the CFD for you, or whether you want us to start from scratch, build the model and then do the CFD at the end, we can do either of those for you. So I'll pass you back now to Nagman to conclude what we've been speaking about and take the questions.
Excellent. Thank you, Paul. We've got just under 10 minutes left and a few questions to get through. Then I'll hand it back to Ian for some closing remarks. So let's go back very quickly. Some of the new features, Duncan, you mentioned, and the GenOp, we have multiple questions about that. The first thing, let's quickly talk about the new weather utility. What is it exactly and how can it be accessed? Just a quick response.
So you can access it from the utility section of the task manager, and if you just run it, you can import EPW files, or and you can basically create task formatted weather data. So you can edit weather in there.
Yeah, it's particularly useful if you're doing like a calibrated energy model and you've got real world weather data. Say you've got a local weather station on site, which is something that we've done for Ballimore projects and other projects. Then you can take your real world weather data from Excel and very easily make a weather file in Tas, which makes a huge difference to the natural ventilation results.
Brilliant. Let's move on to GenOpt. I know we covered that briefly, but I think that slide you showed, Duncan, has a thousand questions behind it. It's so interesting about the heat pump and the gas boiler, right? And the trade-offs between cost and CO2. So we have a couple of attendees asking about GenOpt again. So the kind of things that can be used to optimize, for example, can it do U values for minimizing combined heating and cooling demand? Can it be used to optimize heat pump, COP, SEER, even EPCs, that whole process? Where is the technology right now? How much can be done?
Okay. Yeah, so anything that you can, any variable, you could change that. So, and you also need to know, what you're trying to optimize for. So an example would be, say, overheating analysis. You could enter the TM52 criteria as your limiting value. So that would be your cost function. You want something just to pass that, and you could change, the G value of the glazing, the area of the windows. You could add shading, and you could have those all as different variables that you're testing, and you're trying to meet a pass basically for that overheating criteria.
So I have to ask, Duncan, can you actually change the geometry of the shade? Is that part? Would that be one of the variables that you can do?
Yeah, I mean, you can use feature shading very easily to get
the
proportion of shading. The geometry of the shade, you could change the width. Each one of these will add another step to, in this example, on the slide, that's just using systems. So it's just the systems model, and it's just how it's being controlled in there. If I want to change, say, the window width, I would have to re-export from the 3D model. This can all be done in the optimization program, and it's just which steps you have to repeat, if you like, to get the program to do.
Brilliant.
So there's not much that you can't do with it, really. It's quite powerful.
Yeah, it's coming up with what you're trying to reduce, minimize, and what are the main parameters you'd like to adjust.
Vary, and the more variables you've got, the tougher it gets, I presume.
Yeah, so there's lots of different algorithms for trying to solve it. So because this was a single variable one, I used the golden section algorithm. If you've got multivariable, you could use Hooke's Jeeves.
I think we might need a whole webinar on this one.
Yeah, Duncan's actually agreed to do the next webinar in January on GenOpt. He doesn't know it yet, but he's been nominated to do it. Duncan, just last point on GenOpt. A couple of people have asked, how do you get started? If you're a Tas user and you know about building simulation and you're an engineer, but you've never used optimization, what's a good way to get started? Do you have training resources, training material, example scripts, etc.?
I think initially just contact me at support@edsl.net, and then I'll try and help you with. If it's a specific problem, I may have some scripts and things that I've developed for something similar. So basically just contact me first, and then I can try and help you.
Yeah, we have documentation for it, so you could always have a quick read through just to get a feel of, just get an overview of how it works and what the process is like, and then contact us.
Where's the
Brilliant.
documentation, Andrew? Yeah.
That's on our website. Yeah, so
Okay.
I can put a link to that.
Yeah, in the follow-up email, we'll share all these resources and also provide some written answers to the Q&A. So great question from Nicholas, which is our next topic, which is on CAD, and he's asked about Rhino. So Andrew, this is something you can touch on.
Yeah, I think I actually have a slide that I prepared just in case this came up, because it seems to be a very popular topic. You know, people have been asking, you know, what sort of formats can you get into Tas? So, you know, you can import the usual GBXML, IDF, things like that. And this is just an example to show, here's some geometry that I made in Rhino, and then I used Honeybee in Grasshopper to get the geometry into Tas using the GBXML. Export. So yeah, you can do quite unusual shapes quite easily. Then the bottom example here is quite nice because it goes a semi, you know, a dome, half a dome, and here it is in Rhino, and then you can see it in the middle here in the 3D modeler, and then it goes straight through to the CFD. So yeah, it's very powerful, and yeah, I think it works quite well in my experience. When it comes to CAD, you can import DWGs for drawing around quite easily, and you can have any number of DWGs imported. So it makes it very easy to assign one DWG to each story in your model. And then we can also import 3D shade surfaces from a 3D DWG or DXF, which is really useful if you've got surrounding shade buildings and you want to like import a cityscape, but it's also quite popular for quite useful for if you're doing like a complex shading system. So say for example you've got a building which has got a really complicated external shade, then you can draw it in AutoCAD and bring it in as 3D shade surfaces, and the simulation still remains really quick. Because I know that, yeah, I mean, some of our customers have had you know, issues in other software. It's been a bit slow when they've had quite complex shading systems.
I immediately thought of that Hilson Rand shade,
Yeah, exactly,
which looks like a wicker basket. It's an hideous looking thing.
Okay, fantastic. We've got 2 minutes left. So Ian, a couple of last questions on the CFD bit. One is technical question: can you add load profiles like internal gains in Ambience 3D, and how quickly do the results, can they be updated? And while you're on the topic, how does someone access Ambience 3D? Is it available now? How much will it cost? Go ahead.
Pure consultancy at the moment, but the intention is obviously to turn it into a product. In terms of, can you have variable loads? Can you have variable gains? Can you change stuff around? Yes, but a lot of that is hand coded. So I literally write code for a specific project that I'm working on to put the stuff in the right place. The interface is catching up, but obviously at the moment it's very much an in-house tool, which means it's fundamentally a consultancy tool. But once the interface has caught up and we can have the interface, you know, elements that allow you to do these sorts of things, yes, it's a no-brainer.
Brilliant. And Andrew, a couple of quick questions about Revit as well, since you mentioned Rhino Honeybee. Any comments on that, bringing Revit models into Tas?
Yeah, you can export GBXML files from Revit. In my experience, the quality of the GBXML that's produced by Revit can be a bit questionable, but we have got quite a lot of features in Tas which automatically try and repair poor quality GBXML. So that does solve quite a lot of problems, and we've also got guides on how you can address issues that might arise from the Revit export. Also, you can actually, I did see a question in the chat as well about you know, bypassing the 3D modeler, and you can actually through our automation interface, you can actually, you know, make plugins and things that bypass the Tas 3D altogether and create geometry natively in the building simulator. But again, I think that's probably a topic for another time. It's quite big topic. But yeah, and again, drawing geometry in Tas 3D is so quick and easy that if you have got a Revit model and you're finding that its GBXML is not very good, then you can just export the plans, the DWG plans, and very quickly, all you have to do is just trace around the walls, and you end up with the model very quickly in Tas. And our model is very robust.
Brilliant. Kartikeya, send your Revit file if you want to support at EDSL.net, and the guys will help you bring it in, or at least take a look and give some advice. We're out of time now. It's bang on the hour. There's still a few questions floating around. So what we'll do is we will commit to answering all of those as a follow-up email. So if you've attended this webinar and you registered, you will get the answers, a recording, a copy of the slides. Okay, thanks so much. I'm going to hand over to Ian for some closing remarks.
really just thank you everyone for your time, and hopefully we can help you guys in the future going forwards. We're certainly not going to stop developing the software, and we've got, as I say, sadly, from my point of view, 36 years behind us, and I don't think I've got another 30 in me, but I'll keep going as long as I can. So yeah.
Thanks everyone for joining. Have a good day, and we'll be in touch.
Lovely. Cheers, guys.
Thank
Bye.
you.
Cheers. Cheers.
Thanks.
Hello everyone, and welcome to this webinar on Tas Engineering for Everyone. My name is Nagman Khan. I'm delighted to be your host today on behalf of the team at Environmental Design Solutions.